Welcome back to the today's class on BWE. Today we will be seeing about Kirchhoff's law and mesh analysis problems. Okay, these two are very important in your question paper. Okay, from the first unit, we will be having 8 marks questions from this topic. Okay, first we will be seeing about Kirchhoff's law problem. First question is, find the currents flowing in the resistances in the given circuit using Kirchhoff's law. We have already studied about Kirchhoff's law. First, this is the circuit given in the question itself. Step 1 is you need to redraw the circuit. From the question paper, you redraw the circuit in your answer paper. Okay. Then what you're going to do is mark the points. Okay, you mark this junction point as A and this junction point as B, C, D, E and F. Okay, mark points. Okay, A, B, C, D, E and F. Okay, this is the step 1. Next, you need to assume that the currents are flowing in the clockwise direction. Okay, first you need to know what is a loop. Okay, this one is considered to be one loop. Okay, and this one is considered to be another one loop. Okay, this is the loop 1 and this one is the another loop, that is the loop 2. Okay, so you need to assume the current I1 which is flowing in this direction, in clockwise direction. Okay, second also, the second loop also you are going to assume the current I2 which is flowing in clockwise direction. Okay, there are two loops in this circuit, so there are two currents I1 and I2 which are flowing in clockwise direction in the circuits. Okay, next we are going to step 2. Okay, first you need to find the equation for loop 1. Loop 1 is nothing but A, B, E, F, A. This one is considered to be loop 1 and this loop which is B, C, D, E, B referred to as loop 2. Okay, there are two loops, one is loop 1 and another one is loop 2. Okay, first we will take loop 1 and write the equation for this loop 1. We have already Kirchhoff's voltage law. Okay, as per Kirchhoff's voltage law, you know that the sum of potential rises will be equivalent to the potential drops in the circuit. Okay, so the potential rise in the circuit will be equivalent to the potential drop across the circuit. So we know that potential rise is nothing but the battery which is present in the circuit. So this battery is 30 volt. Okay, for loop 1 we are having a battery of 30 volt. So the potential rise is 30 volt, which will be equivalent to sum of all the potential drops across the circuit. Okay, so we need to find the potential drops along the loop A, B, E, F, A. Okay, A, B, E, F, A. Okay, for that, first we have know the potential rise is 30 volt. So we have put the 30 volt over here, which will be equivalent to the potential drops. Okay, for the potential drops, as per the Ohm's law, we know V is equal to I into R. Okay, so we have assumed the current which is flowing in the clockwise direction. So this is the current I1 which is flowing in clockwise direction. So this current I1 will passes through the 5 ohm resistor, 20 ohm resistor and return back to the battery. Okay, for the loop 1, I am saying only for loop 1, the current I1 will be flowing through 5 ohm resistor, 20 ohm resistor and it will return back to battery. So for that we need to find the drop. So we are going to multiply 5 into I1, okay, which is 5 I1, which is nothing but the potential drop. V is equal to I into R. Okay, I1 is I and R is nothing but the 5 volt. We already know Kirchhoff's voltage law says that potential rise will be equal to sum of all the potential. Okay, it is the one potential drop. We need to find all the potential drops across the circuit. Okay, so the second potential drop is nothing but here. The current I1 starts from here and flows through the first resistor, which is 5 ohm. So we are putting 5 into I1. Second, this current I1 goes into this resistor, which is nothing but 20 ohm. So we are getting plus 20 I1. Okay. Next, this I1 current will return back to the battery. Okay. Then you need to see that this point B to E. Okay, this resistor is connected across B to E. Okay, this B to E, you can see the current I1 is flowing in this direction from B to E, whereas in the second loop, the current I2 is flowing in the reverse direction, whereas E to B. Okay, whereas I see the current I1 direction, it is from B to E. Okay, if you find the current direction in I2, the second loop, you can see the I2 is coming from E to B. So for the first loop, you need to do extra one thing, that is nothing but minus 20 into I2. Why this minus comes over here? Okay, this minus comes because the I2 current is opposite in the direction of I1 current. Okay, the I1 current is the reference for the loop 1. Okay, this is the loop 1. You have assumed I1 is flowing through this 20 ohm resistor from B to E, whereas when you see I2 current, the I2 current is flowing from E to B. Okay, it is in the reverse direction of the I1 current. So we are going to make minus 20 I2. Okay, this is the main point you need to work out over here. Okay, next we can solve this equation or simplify this equation. We get 30 will be equivalent to 5 plus 20, you will get 25 I1 minus 20 I2, which is the equation 1. Okay, next what we are going to do is we are going to move to the loop 2, which is nothing but B, C, D, E, B, which is nothing but B, C, D, E, and B. Okay, in this loop 2, you can see the current I2 is flowing. Okay, for this current I2, you can see the equation comes like this. You need to check the current flowing through the battery direction. Okay, first you need to find the current is flowing from negative terminal of the battery towards the positive terminal of the battery. Okay, from negative to positive terminal of the battery. So we will be getting plus 40 volt. Similarly, here also you see it is plus 30 volt. Why? Because the current is flowing from negative terminal of the battery towards the 30 plus positive terminal of the battery, because I1 current is in this direction. Similarly, here the I2 current is also flowing from negative terminal of the battery towards the positive terminal of the battery. So we are getting plus 40 volt is equivalent to, next we are coming here, which is nothing but 20 I2 plus 10 I2. Okay, so these two are the same. Okay, because of Ohm's law, we are getting 20 into I2, which is nothing but the voltage drop, and another 10 into I2, which is nothing but the voltage drop over here. Then we need to find the next one, which is minus 20 I1, because as a reference of I2, the current I2 is flowing from E to B direction. Okay, similarly the current I1 is coming from B to E direction. Okay, so the current I1 is in opposite phase, so we need to make minus 20 into I1. For this loop, you need to find A, B, E, F. Okay, for this thing, you need to check I1 as a reference. So we are getting minus 20 I2. Whereas in the second loop, which is B, C, D, E, B, this one I2 is the reference, so you are getting minus 20 into I1. So now we are going to simplify the equation. Nothing but 40 equal to minus 20 I1 plus 30 I2, which is equivalent to second equation. So we need to solve this equation now. You can use any mathematical method to solve this two equation. You can use a calculator, or you can use the any other method you have studied in the 12th standard or 10th standard to solve the linear algebraic equation and find the two unknown values, which is nothing but I1 and I2. After finding the unknown values I1 and I2, please tell the values. Okay, I am giving a small assignment to you. Find I1 and I2 values now and tell me now. Okay, the current I1, okay, which is flowing through the resistance 5 ohm, is nothing but 4.8571. Okay, please make this in engineering. You need to have minimum of 3 decimals. Okay, if possible, you may have 4 decimals. Okay, minimum of 3 decimals in engineering, you have to make it. Okay. Next, the current I2, which is flowing in 10 ohm resistance. Okay, if you see, the current I1 will be flowing through this 5 ohm resistor, which is nothing but 5 ohm resistor is I1. Whereas in 10 ohm resistance, the current I2 will be flowing. Okay, for I2, you will be having an ampere rating of 4.5714. Okay, then for current I3, for current I3, where is the current I3? Anyone can say? Here is the current I3 will be flowing because the I1 current is flowing from B to E direction, whereas the I2 current is flowing from E to B direction. Okay, it is from B to E. I1 is from B to E, whereas I2 is from E to B. Okay, so due to this anti-clockwise rotation of I2 and I1, so you can see I1 is from B to E, whereas I2 is from E to B. So we are going to find the new current which is flowing in the 20 ohm resistor. So the current flowing through the 20 ohm resistor is I3, which will be equivalent to I1 minus I2. Okay, because due to this difference, I1 is from B to E, whereas I2 is from E to B. So you need to subtract I1 minus I2, which is nothing but 0.2857 amperes. Okay, this is a very easy problem. Did you all understand? If you have any doubts, please ask. Okay, this is the problem 2. Okay, here you can see, find the currents flowing in the resistances in the given circuit using Kirchhoff's law. Okay, the difference between the first problem and the second problem, anyone can see the difference? What is the difference in first problem and second problem question? See the circuit. This is the circuit for the second problem, and this is the circuit for the first problem. Anyone can find any difference?
The battery.
Yes, battery. Yeah, correct. You can see here the battery, this 40 volt is from negative terminal to the positive terminal. Okay, whereas here you can see the battery is from positive to negative terminal. Okay, this is the very small difference. In this small difference you will get everything different. Okay, all the values different. Okay, I will tell you how this made. Step 1, same. Mark all the points A, B, C, D, E, F. Okay. Next, assume two currents in the clockwise direction. So, you always assume the currents in clockwise direction. Please don't assume in reverse anti-clockwise direction. Okay. Always assume the current in clockwise direction for all the problems given to you. Okay. Follow the same practice. Always assume in clockwise direction. Okay. Assume two currents I1 and I2 in two loops. Okay, now what you are going to get is for loop 1, you can see the current I1 is flowing through the battery from negative terminal to the positive terminal and through the resistance 5 ohm. and through the 20 ohm resistance and returning back to the battery. Okay, if you see, the current I1 direction is from negative to positive terminal. So from negative to positive, it is coming up. Okay, it's minus to plus, it is coming up. So you are getting plus 30 volt. Okay, which is equivalent to, others are same. You are going to get 5 into I1, 20 into I1, and another one is, here you can see B to E. So there are two currents flowing. One is I1 and another one is I2. Whereas I1 current is flowing in the direction of B to E, whereas I2 current is flowing in the direction of E to B. Okay, so what you have to do is you need to subtract minus 20 I2. Okay, you need to put minus 20 I2. Okay, this is the difference. Okay, next, you need to simplify this equation, which is nothing but 30 equal to 25 I1 minus 20 I2. Okay, this is the same step for the two problems. For the first problem and the second problem, the first loop is the same. There will be no difference. Because in the second loop, there is a difference. I will tell you. Here, when you see this, the current direction is in clockwise direction, but you see the current is flowing from positive terminal of the battery towards the negative terminal of the battery. So it is, there is a fall. Okay, it is going from plus to minus. So what we need to do is you need to put minus 40 volt. In the previous problem, you had seen the difference. It is from minus and plus. So we get, in the previous problem, we have plus 40 volt. Whereas in this problem, the current is flowing from positive terminal towards the negative terminal of the battery. So there is a voltage drop or a drop in voltage. So we are getting minus 40 volt, which will be equivalent to, similarly, you can say 10 into I2, 20 plus 20 into I2, and minus 20 into I1. Why this minus 20 into I1 comes? Because you can see the current I2 is flowing from E to B direction, whereas the current I1 is coming from B to E direction. Okay, so we are getting minus 20 I1. So simplifying this equation will give you minus 40 is equal to minus 20 I1 plus 30 I2, which is the second equation. Now we are going to solve this two equation by any one of the mathematical method. Someone please tell me the answer. Solve these two equations. 30 equal to 25 I1 minus 20 I2, equation number 1. Minus 40 is equal to minus 20 I1 plus 30 I2, which is equation number 2. Solve these two equations and tell me the answer. Okay, I1 value, that is the current which is flowing through the 5 ohm resistor. Okay, the value is 0.2857. Okay, similarly, the I2 current which is flowing through the 10 ohm resistor is nothing but minus 1.1429 amperes. Okay, so to find the current I3, what you have to do is you need to know that the current I1 is from the direction of B to E, whereas the I2 current is in the direction of E to B. So due to this thing, you need to subtract I1 minus I2. Okay, so the current I3 which is flowing through the 20 ohm resistor is nothing but current I1 minus current I2. You will be getting a value of minus 1.4286 amperes. Okay. Okay, let us move to the next problem. Okay, this is the same problem, but you are going to find three equations. Okay, there are three loops. So the step one is same. What you need to do is mark all the points A, B, C, D, E, F, G, H. Okay, now you need to assume the current directions, which is nothing but all the current direction. You are having three loops, so assume three current directions. Three current directions need to be same as in the clockwise direction. So the current I1 is flowing in this direction and the current I2 is also flowing in this direction. and the current I3 is also flowing in the same direction. Okay, you are assuming three current directions. Next, you are going to the loop 1 equation. Okay, what you need to see is the current. You need to start from the battery. Here you can see the current I1 is flowing from negative terminal of the battery towards the positive terminal of the battery, because here you can see the current is from minus to plus, so there is a rise in potential. So you need to put 30 plus 30 volt, which will be equivalent to, you can see, 5 into I1, 20 into I1. And the same time, you can see the current I1 is from B to G, whereas the current I2 is from G to B. So it is minus 20 I2. Okay, so we will be getting, please wait a second. Okay, so if you see, the current I1 is from B to G direction and the current I2 is from G to B direction. So you are getting minus 20 I2. So now you are going to simplify this equation. You will be getting 30 is equal to 25 I1 minus 20 I2, which is equation number 1. Next, you need to find for the loop 2, which is nothing but B, C, F, G, B. This one is the loop 2. Okay, here it will be interesting. You will be getting three currents, I1, I2 and I3. How? First, you need to see, is there any battery source available over this loop? Here in the loop 1, you will be having a battery voltage of 30 volt. In the loop 3, you will be having a battery voltage of 40 volt. Whereas in loop 3, do you have any battery voltage over here? All the three are resistances. Okay, so if there is no battery voltage, you are going to put 0 volt. Okay, here no battery, here no battery, here no battery, here also no battery. So you are putting 0 volt will be equivalent to 20 into I2, 10 into I2, then 15 into I2. Okay, you can see from here 10 I2, 15 I2, 20 I2. Okay, it starts from here 10 into I2, 15 into I2, 20 into I2. All are in plus, plus 10 I2, plus 15 I2, plus 20 I2. Next, you need to compare with the two loops on either sides. First, you will be seeing with the loop 1. You see the current I2 is from G to B direction and the I1 current is from B to G direction. So what you're going to make is minus 20 I1. See, it is here minus 20 I1. And for the loop 3, you can find the current is from, I2 current is from C to F, whereas the I3 current is from F to C. So you are getting minus 15 I3. Okay, 10 I2, 15 I2 plus 20 I2 equal to minus 20 I1 minus 15 I3. So simplifying these three equations, you get minus 20 I1 plus 45 I2 minus 15 I3 will be equal to 0. This will be the second equation. Okay, anyone can tell what is the third equation? Please write the third equation now. Write the third equation now. See, the loop 3 equation is nothing but, you can see the current I3 is flowing from negative terminal of the battery towards the positive terminal of the battery. So it is a rise in potential. So you are getting plus 40 volt, which will be equivalent to 15 into I3, 25 into I3 minus 15 I2, because the current I3 is from F to C direction, whereas the current I2 is from C to F direction. So the direction get reversed. So you are getting a minus 15 I2 value over here. So on simplifying this equation, you will be getting 40 equal to minus 15 I2 plus 40 I3. So solve these three equations and tell what is the value of I1, I2 and I3. Okay, tomorrow I will ask you what are all the values for I1, I2 and I3. Okay, Next, we will be moving to the fourth sum.